Three vectors having magnitude a, 2a, and 3a meet at a point, and the directions are along the diagonals of the adjacent faces of a cube. Find your resultant vector. Okay, let us begin. So here we will consider a cube of unit length. That means each side of the cube are going to be of 1 unit. So here we have a cube. Now let's name the vertices of the cube. So we have A, B, C, D, E, and F. We will be considering 3 adjacent faces. That means we'll be considering the face O, A, B, C. Then we have the bottom face O. We also need another point G. O, G, F, A, and this face O, G, D, C. Now here in this coordinate system, I cap is going to be the unit vector along the x-axis. J cap is going to be the unit vector along y-axis, and K cap will be the unit vector along the z-axis. Now let's start with the face OAFG. For the face OAFG, here OF vector, so let's join point O and point F with the helper vector. So point OF vector is going to be the diagonals for this particular face. Now we can easily define the vector OF in terms of the unit vector I cap and J cap. Now because the diagonal OF vector lies on the xy plane, so we have 1 unit multiplied to I cap added to 1 unit multiplied to J cap. Let this be equation 1. Now here we are choosing the magnitude to be 1 unit because we have already chosen a cube of unit side length. Next we are going to consider the side OABC. Now for the face OABC, now here OB vector is going to be the diagonal. So OB vector is the diagonal, or you can say the face diagonal. Now since OB vector is the face diagonal and it lies in the xz plane, then OB vector is going to be given by I cap plus K cap. That's going to be number 2. And then we're going to consider the face OCDG. So for the face OCDG, here I would like to add a comment. So there is no specific order or way in which we choose the adjacent faces of the given cube. So you can choose any particular side as long as they're adjacent, and the vector must start from the one common point. Here we have OD vector. OD vector is going to be the face diagonal. We have the face diagonal, and since that face lies in the YZ plane, so OD vector is going to be equals to, we have I cap, it's going to be J cap added to K cap. This is going to be equation number 3. Now we have the vectors along the face diagonals. Now what we'll do, we'll find out the respective unit vectors. So here we can find out the unit vector OF, or you can say unit vector in the direction of OF is going to be equals to, we'll take OF vector and divide it by its magnitude, which is magnitude of OF vector. So what is OF vector? So that's I cap plus J cap. When you divide it by its magnitude, that's simply going to be square root of 2. So that means we have 1 over square root of 2 multiplied to I cap plus J cap. We're going to label this as number 4. Then we will find out the unit vector along OB. So that we have OB cap. So that's going to be, take the vector OB and divide it by its magnitude OB. So this is going to give us 1 over square root of 2 multiplied to I cap plus K cap. Let's label this as equation number 5, and then we will find out the unit vector along OD. The OD cap is going to be OD vector divided by the magnitude of OD vector. That's going to be 1 over square root of 2 multiplied to J cap plus K cap. This is going to be equation number 6. Okay, now that we have the unit vector, let's go back to a problem. So here we need 3 vectors, and each of these vectors are going to have magnitudes A, 2A, and 3A. Okay, now these are going to be in the directions of diagonal. So let us suppose that the vector along OF has a magnitude of A, vector along OB's direction has a magnitude of 2A, and vector along OD has a magnitude of 3A. So here that means we have, let's call this as the vector A. The A vector is going to be, we'll take the magnitude A and multiply it with OF cap. Now this is going to give us the vector A, which has a magnitude of A and is along the direction of OF cap. Now this is going to be equals to, we have A over square root of 2 multiplied to I cap plus J cap. Next, we're going to consider another vector B. Now we're going to choose B vector such that B vector has a magnitude of 2A and its direction is along OB cap. Now that means we have 2A over square root of 2 multiplied to I cap plus K cap. And then we have, let's call it the vector C. A vector C is going to have a magnitude of 3A and this is along the direction of OD cap, where we have 3A over square root of 2 multiplied to J cap plus K cap. Now finally, what we do, we'll take the resultant. So resultant of these three vectors, A vector, B vector and C vector, that's going to be simply take the sum. So we have A vector added to B vector plus C vector, which means that we have, we'll take A over square root of 2 as the common vector. It gets multiplied to I cap plus J cap plus 2I cap plus 2K cap plus 3J cap plus 3K cap. And this is going to give us, now we have A over square root of 2 multiplied to, so I cap plus 2I cap, that will be 3I cap. J cap plus 3J cap, that's 4J cap. And then we have 2K cap and 3K cap, giving us 5K cap. So this is going to be the resultant vector. Now let's find out its magnitude. So magnitude of A vector plus B vector plus C vector. This is going to be A over square root of 2 multiplied to the square root of 3 squared plus 4 squared plus 5 squared. So taking the sum of the squares underneath the square root, that's going to give us 50, or simply said, this is going to be, let's write it down. So this is going to be square root of 50. And what's square root of 50? That's simply 5 times square root of 2. We can factor out the square root of 2. That leaves us with 5a. So that means the magnitude of the resultant of the vectors a, b and c such that a has a magnitude of a, b has a magnitude of 2a and c has a magnitude of 3a. It gives us 5a, and it's given here that a vector, b vector and c vector are along the diagonals of the adjacent faces of a given cube.